Hey guys, welcome back to the Dueling RCA restoration projects. So what we're looking at here is the tabletop set, the one that is actually working fairly well when we last left off. And I was contemplating going in deep to remove all the crud and corrosion in the center. Well, that's exactly what I did. I went ahead and unmounted the yoke and the focus coil, which wasn't too bad. 4 wires in the yoke, one of which goes through this whole high voltage box, and 2 for the focus. And dumped everything in Evapo-Rust, all the parts, all the pieces, and everything came out very nice and clean. The yoke has no steel parts really other than this, and it had no corrosion, so that was put aside. The rubber pieces come off, and this was soaked in Evapo-Rust, as was the focus coil. I was a little on the fence about that because it has a hole in it, and yes, liquid got inside. I have baked it out in the oven, and I think we're pretty good. Some liquid came out after I let it cool down a bit. It's still quite warm now, but then I realized, oh, that's probably wax. So I got it on my hand, and got very sticky, so I'm pretty sure that's not moisture. I'll let it sit this for a while before I power it up. Something definitely to be concerned about. But you know what? Part of the reason for me doing this and going in, this is tedious, time-consuming, not much fun. I scraped, I sanded, I used Evapo-Rust, I used CLR, and then I used Bow Shield T9 corrosion-inhibiting wax over the whole surface. Not much fun, but part of my reason for doing this, one, is the owner has sentimental value for this set, and I told him I did my best. 2, if you recall, I picked up an RCA TVs. They're very cool Art Deco styled set, a little bit earlier than this RCA, and it is even worse than this one, and I kind of wrote it off, especially because somebody gifted me another one in better condition. But now that I've seen, yeah, it is possible, and it's a fairly similar chassis to this, so it'd be very similar work. What I'm thinking about doing with that chassis is, if I can get a big enough tub and scrape together enough money to buy a few gallons of Evapo-Rust, is just dunk the whole darn chassis in there. Somebody mentioned, half joking, I think, about using a hose on this, taking it to the car wash. That wouldn't get off this crud. That was baked on rodent excrement fused with corrosion and years of filth. Water, high pressure hose isn't going to get that off. Not the corrosion especially. A bead blaster, perhaps, but I'd be worried about it damaging these sockets. And it'd be a lot of work to cover up and protect everything, the coils and all that stuff. So I'm curious what would completely submerging this in that Evapo-Rust do. It's pretty benign stuff. It's not acid. It's pH neutral, I do believe. It uses a different type of process called chelation. It's not acid, it's not electrolysis. So my point being, it shouldn't harm anything else other than it getting damp. And it works fairly quickly if you have fresh solution and the temperatures are in the room temperature range or better. And then, of course, I would put it out. I'd do this in the summer, ideally, when it's dry and warm, and let the thing bake out in the sunlight for a week or two. Too big to put in the oven, realistically. I'd be worried about wax flowing out of stuff like the flyback and stuff. So that would remove some things, but I'm curious as if that would work. So we'll see. At any rate, I'm basically done with as much corrosion removal of this as I care to do. We can start working on reassembly. I took reference photos. I also have another identical chassis, so I know how this goes back together. Now, another interesting thing is what used to be back here. I took out that Candohm resistor that was along the back here. So there's 2 screws, you take those off, that gets this cover bar off and reveals this guy which was still bonded to the chassis. Turns out there was about an 1/8 inch thick pad of asbestos behind it. You can still see some traces of it here. And it was just sort of glued on there. Well, what I did is I got it wet. I soaked it down with water. One, it loosened up the bond with the metal. Two, it keeps the fibers from becoming airborne, which is the big danger here, is to breathe in those fibers. I then clipped off the connections and scraped all this down. There's no asbestos left on the chassis now. So what am I going to do? I got to replace it with something. Well, one thing I realized is the heat is not being transferred to the chassis. That's what that asbestos pad was for. This is aluminum. This is the heat sink for it. The specs for these 3 resistive elements in here add up to about 20 watts, 24 watts. If it hits the maximum wattage listed in the service info, it's probably more like half of that. So it's not all that much aluminum, no fins or anything. When I first saw this, I assumed it must get super hot, and that's why they put it out here, but no, not really. What it comes down to is components back then could not tolerate heat very well compared to modern components. So modern resistors for the same wattage are so much smaller, as they can dissipate heat more efficiently, and they can tolerate getting very hot themselves without going out of spec. So what I ordered up are 3 aluminum housed resistors. Now another interesting thing is that what used to be back here, I took out that Candohm resistor that was along the back here. So there's 2 screws, you take those off, that gets this cover bar off and reveals this guy, which was still bonded to the chassis. Turns out there was about an 1/8 inch thick pad of asbestos behind it. You can still see some traces of it here. And it was just sort of glued on there. Well, what I did is I got it wet. I soaked it down with water. One, it loosened up the bond with the metal. Two, it keeps the fibers from becoming airborne, which is the big danger here, is to breathe in those fibers. I then clipped off the connections and scraped all this down. There's no asbestos left on the chassis now. So what am I going to do? I got to replace it with something. Well, one thing I realized is the heat is not being transferred to the chassis. That's what that asbestos pad was for. This is aluminum. This is the heat sink for it. The specs for these 3 resistive elements in here add up to about 20 watts, 24 watts. If it hits the maximum wattage listed in the service info, it's probably more like half of that. So it's not all that much aluminum, no fins or anything. When I first saw this, I assumed it must get super hot, and that's why they put it out here, but no, not really. What it comes down to is components back then could not tolerate heat very well compared to modern components. So modern resistors for the same wattage are so much smaller, as they can dissipate heat more efficiently, and they can tolerate getting very hot themselves without going out of spec. So what I ordered up are 3 aluminum housed resistors. Alrighty, parts have arrived that should allow me to wrap up this set. As always, no matter what I try to keep on hand, I'm always in need of something. So here is the refractory material I ordered from Amazon. I was a little bummed that it needs to go from here to here. It's like 1/2 inch, 3/4 of an inch, not wide enough, but I'll just cut 2 strips and I'll split them somewhere in a convenient spot. I've never used it before, but I think it'll work out fine. It's very similar thickness to the material that was on there. I think it's good to do a couple thousand degrees or so, 2100 degrees. Here's what I got. Lin 2260J universal gasket paper, 10 by 7, 1/8 inch thick, high temperature gasket paper, soft plywood material, cut your own gaskets, yada yada. It's meant for using like in furnaces or whatever. I mean, if it can handle that, this is be a piece of cake. The rest of the stuff I got from Mauser. This would be the power resistors and a thermally conductive insulating material for bonding them to the heat sink. Turns out actually I have 2 projects that need this type of work done, so I got a bit extra. So this is the bonding material, the sill pads, I call them, I guess. Thermal interface product, to be specific. So instead of thermal grease, it's a thermally conductive, electrically insulating material that you put between your part and the chassis. So it doesn't conduct electricity, but it does conduct the heat away. And it's similar to the refractory material. It comes in a big square, or I got a smallish square this time, and you just cut down to size. I'm not sure if they're adhesive or not, but it's like this. It's kind of a flexy material. It could have silicone gel or silicon gel or something like that inside. Oh yeah, I see. Yeah, you peel this off. It's going to be sticky on both sides. That's good. All right, so what do the actual resistors look like? I think this is one of some caps. Yeah, here we go. I think originally there were 2 620s. I got 680s. Sorry, originally 2 650s. I got 2 680s, and then an 850. I think I got an 820. That should all be well within tolerance. And they are tiny. Relatively speaking. So here are these guys. I think these are 10 watt rated. Originally, I think they said they needed to be 5 watts. So we got these 2 guys, which go in between these 2 sections, I think. And then there's an 850 in here somewheres. So these will mount to this. So the sill pad, or the thermal material, will go on the back of this aluminum piece, and the resistors will mount to this. And then the refractory material here, and then this screws to this. And here's the 820, so I'll mount them something like that. Originally, it also had this on here, but it's a little too, it's not quite enough clearance. It bumps on the top of that. I could put some spacers in there if I really want to do it, and then it hides them, essentially. I guess I could mount these this way, and then like that, and then it clears these guys no problem. But this is a little too fat. This is a little bit higher rated. This is a 25 watts. These are 10s. This is 25. If I had a couple washers or something for spacers, get that up there. And then, unless you looked really close, you wouldn't know. Just drilling the last of the holes for the power resistors. It's very easy to drill through this aluminum. I decided to mount them kind of like that. You may be surprised to see that I'm using a hand drill, but I like to for a few reasons. 1, I often work late at night and I don't want to make that much noise. 2, I like using old tools. 3, I like having more control. And then this stuff is so easy to drill through. Why not? Alright, just grab a larger drill bit and just run it around a little bit to clean up the rough edges. Backside too, and I'll grab some little screws, the mounting holes on these little 10 watters are especially small. There's little tiny holes there for mounting these. Alright. Turns out that's actually a bit of corrosion and black material flaked off, so there's nothing really to clean off there. Alright, so let's cut up one of these pads here and do the big one first. Just going to use some scissors here. Eyeball it. So, there. And, yeah, pretty good size there. Okie dokie. Figure I'll start by sticking it to the back of the resistor. Ooh. Not quite as sticky as I thought it'd be. Just kind of need to hold it in place. Cut it a little bit too small. But, yeah, I think it'll be alright. After all these are way oversized. Yeah, actually it's not really sticky at all. I think that backing is there just to keep it clean, maybe? Alrighty. Ideally I'd have some self-tapping screws or something because I don't want things to stick out too much in the back because this has got to mount against cabinets. So I'm going to put the screw heads on the back because they're pretty low profile. I'll put a nut and washer on the other side. These extra screws might be a little too short. I got some longer ones. Let's give it a try anyways. Just barely long enough to hold on, but that's the idea. Alright, here's a Phillips screwdriver. Let's give it extra tightening there. Alrighty. Of course I'll have to extend the wires, so the original wires are going right to lugs right there, and I cut them off so that they're not going to be long enough to reach over. Nice. Alright, let's get the last two. Now, the last two, these are so small, even my smallest screws. These are number 7, I think. They're too big. I need number 8. Or rather, those are number 5. I need number 4 screws. Let's see if I can dig some up. Alright, I found some teeny tiny screws. Some teeny tiny locking washers. At least the smallest locking washers I have. Yes. There we go. So, got the little guy on there too. Itty bitty screws. I think that turned out quite well. Remember, there is a band I'll put over this to hide those new parts a little bit. I did end up having to install new wiring. For the most part, going to these, I think just a couple wires I was able to retain. Now I'd like to power it up again to make sure it still works, but before I do that, I had removed the yoke and focus coil while removing the gunk from the chassis, and I still need to wire up the last replacement electrolytic can cap. So a little bit of work to do, and then assuming all goes well, we're almost done with this, I think.